But anyway, let's get into this. So yeah, today we're going to be talking about mod 2 section 16. And I actually don't even remember what the section's actually called. So working with JSON and XML. And basically there's a couple things going on there. The first half is basically explaining JSON, XML. And then after that, it starts talking about recursion. And then even after that, it talks about NoSQL databases very briefly about NoSQL. Just enough to kind of tell you this is what they exist kind of deal. So we won't talk too much about NoSQL databases today. I think mostly because the curriculum says everything you really need to know about it at this point. Just know that NoSQL relational databases, basically, it's different from SQL where everything's table-based. NoSQL databases basically do other kind of relationships with each other. They're actually very interesting, I think. And one of them, I have more experience in Hadoop, but there's a whole bunch of things like MongoDB, Hadoop, and they have different ways of relating, which includes the way they're structured allows for basically backing up. There's a really extreme one too. It's the IPFS, interstellar, I think it's interplanetary file system. That's literally what it's called. And it's literally designed to, the idea as being, oh, in case you ever need to transfer files across different planets kind of deal, or space, how do you make sure you have all that data? Because right now, when we go, previously, if we want our data from another server, we can just ping it, in real time. And there's a slight delay because, speed of light, but it's relatively small, within less than a second for the most part. And then maybe the server takes a little longer to get up, but actually communicating with it's very, very quick. But if you had something that's not as very quick, that's what the IPFS is. So there's a bunch of interesting ways you can store data, which as data scientists is pretty important. But kind of peeling back the curtain a little bit of why we're doing this in section 16, why JSON XML, and then of course recursion. This is kind of prepping you for section 17, which talks about APIs and web scraping. So the idea here is that we'll usually, the data we have, we might get it from another server. So hopefully, if someone has a nice formatted database, right? We have in this, get a CSV file, or we can use SQL to get it. But sometimes it's not formatted in that way. A lot of times we'll get stuff from a web API. And usually in web APIs, they'll either send you, most likely, a JSON file, which we'll talk about what that is, and an XML file. And those are the things that you have to parse through. And those things in particular, you're not always sure what the structure is to begin with. And so you have to make sure you kind of traverse through it. But that's kind of the standard, is either JSON and XML. That's kind of the go-to part. So this is kind of what we're getting set up to. And then later on, as we get into more web scraping, we'll talk about HTML, which you'll see if, who's ever seen HTML, the code-wise? All right, if you've seen it before, it looks very similar to XML. XML essentially is a generalized HTML format. But that allows us, if you know how to go through XML really well, you'll know how to scrape HTML because it's the same structure. And a lot of times that data that we want doesn't exist. So we can basically, like I said, scrape, kind of go through the HTML file on the web and literally pull out the information that we want, or at least find the information. So
when you say that, just a quick question, is that just pulling the HTML? Is that ignoring the CSS and whatever else that might be running on the page?
No, you can actually, you can actually pull the CSS with it too. So the HTML is kind of we'll talk about it a little more next week too, but HTML is kind of more, it says everything that's going to be shown, and it refers to CSS and then possibly even JavaScript, JS.
Right.
Yeah. So you can actually get the CSS too. So if that's an important part of your scraping, for the most part, most data that we're interested in isn't really CSS based, but it does exist and you can do it. Cool. All right. Yeah, and we'll talk more about that too next week. But I was kind of prepping you saying why we're doing this, and then this will lead into our next few sections. Okay. All right. So let me go ahead and share my screen. And oops. It didn't take me forever this time. Okay, good. I don't know, maybe it was too long still. So you guys can all see my screen all right? Yeah, cool. All right, so we are gonna be talking about JSON and XML. And so let me go ahead and share out this Colab notebook. Oh, I also forgot. because I realized I've been making all these Colab notebooks, and I'm like, well, I'm making them in a Jupyter notebook and then upload them. I was like, well, I'll just keep it in a Git repo. So I do have this Git repo of like basically all the Colab notebooks I've been making, and like maybe modifying too for like other cohorts. You can go to here and check it out too. So for example, today's lesson, it's in mod 2. And then I separated and set it by sections, by like subjects. That way it's a little easier to kind of say, well, like I don't remember what section it is, but we talked about this. You can find that part. So for example, we're going to talk about JSON. We have some sample stuff and the recursion. And for the most part, this is going to be exactly what we see in the Colab notebooks. Just know that you can find it through that way. And I'll make sure to Slack it out to you guys too. Okay. But on to our JSON. So JSON and XML are kind of basically just different formats to package data. And they rely basically on kind of nested sections. And we'll talk about that. So the first thing we're going to talk about is JSON. I believe the curriculum actually puts XML first, but I think JSON makes more sense because it's formatted very similar to Python structure. But JSON stands for JavaScript Object Notation, and JavaScript meaning the same JavaScript that we use for the web. And basically, you can think like JSON objects are legitimate JavaScript code. Okay, so that's really what we're seeing when we're looking at this guy. So this right here is a JSON format, right? And you can kind of quickly look at this, like, you know, it's kind of got this spacing and everything, but for the most part, it might look familiar. So what does this look like to you guys when you see this? Like, at least from what you guys have seen, and like in Python.
It's kind of like a dictionary.
Yeah, it looks like a dictionary. In fact, it turns out when we get our JSON file, it will be a dictionary. So you can see right here, our curly brace, right, that gives us a dictionary. We can see this right here. This would be our key, right? In this case, the key points to another dictionary, right? Because in Python, we can have a dictionary, the key and the value. The value can be any other Python, entity, right? So you can see here, this is another dictionary within here, another key. In this case, it's just a string, a key, a string, and then this one's another key with another dictionary, right? And that's really what JSON is. And you can also notice here in this dictionary, this pop-up. So you can kind of imagine this is a dictionary within a dictionary, and then within that dictionary, there's this key, which this right here, that looks like a list, right? And that turns out when we do translate into Python, it is a list. In JavaScript, they're actually arrays. So we don't list are a special thing for Python, but in JavaScript, in most programming languages, we'll call them arrays. And you'll see that in this case, this is an array or a list of dictionaries. And you can see another dictionary here, another dictionary here, another dictionary here. Okay. So you can kind of see how this has structure, but at the same time too, like dictionary within dictionary within dictionary, it can be kind of cumbersome and say, like, how do you go through this? And so we'll actually see later in recursion, that's actually how we'll traverse this JSON object. Okay. But a couple things to note is that JSON objects, or sorry, JSON in general. So our JSONs basically can either be objects, and objects are really dictionaries. So in JavaScript, we saw in Python how we define an object. In JavaScript, you literally use this basically our dictionary notation. That's how they do objects itself. Okay. And then we have arrays, which are like lists. Of course, we have strings. We also can have numbers in there. And then Boolean. Note that for JavaScript, it can, instead of being a string, like a string of like true or false, it can literally just say true and false, but it'll be lowercase. So note that in Python, it's uppercase, but in JavaScript, it's in lowercase. But when we do read it in there, we'll actually get our true as our capital T, legitimate Python. And then there's one last thing that we haven't really seen too much. You might kind of recognize in the sense of when we're doing pandas is null. And null is kind of the equivalent to none for Python. Also kind of you think of like NA for, well, NaN values, NaN, when we talk about pandas. When we're inputting things in, those are kind of like mostly interchangeable. Null in JavaScript, has anyone programmed in JavaScript by chance? Any web development, anything like that? Okay, all right, see a hand. Okay, good. Yeah, so yeah, in JavaScript, null can give you a lot of weird things. So it's a little different from none, but for the most part, when we import our JSON into Python, this will be translated into a none value. Okay. Cool. So that's the quick introduction of what JSONs look like. Now we can actually use Python to get this JSON Okay, so there's a library here. This is from the curriculum too, but basically it is the documentation for Python about JSON objects. But we're just gonna ignore this part, but check that out when you can. It's a pretty long documentation to check out, but it's good to practice. So here, basically just importing a package that's built into Python called JSON. And in this case, I'm basically just opening up a file. In this case, I actually have a file I put into here, sample.json. And again, this is actually from the curriculum too. So you can check out that same file. And we're going to import, or we're going to open that up. And then we're going to take that data and load it, basically loading that file into a JSON format. And we're taking it, sorry, let me slow down. You're taking a JSON format and importing it into a Python-esque data structure. So first of all, let me show you what this file looks like. And what's nice is Colab here actually allows me to, what's it called? It actually lets me see the structure. So you can see right here, this is the actual file. It's a dictionary, and then we have a dictionary called meta. And then in that dictionary is another dictionary called view. And you can see all these values in here. And some of them are integers, for example. Some of them are strings. I think we might have a couple, yeah, here we are, a couple arrays, which will be interpreted as list. In this case, this key points to a list of dictionaries. So you kind of have these different varied formats. So if I actually run this now, I can actually import this JSON, and I can actually read this data. And you can see here is that, is this the right one? Oh, because I'm looking at data. Okay. Yeah, so you can see right here is that it's formatted basically in the same structure. And this, the reason why this happens is because, can I close this? No. Here. There's actually two dictionaries. There's a data dictionary and a meta dictionary. I believe, here's the data. So see, this is this part. It just ordered it in different structure. So it did alphabetical in this case. But you can see data right here, and that's the same exact thing going on here. And so, like you guys said, this is in fact a dictionary. So I can actually take this type now and check that out. Oh, I don't know, I jumped all the way down there. Okay, you can see it's a dictionary. So that's what's going on here. Normally, if this is just a file, remember, now what's nice is that Colab and some programs will make it nice and neat and pretty. And sometimes, I don't think Colab does, maybe it does, but I'm not familiar with it. You can actually close these tags to make it a little easier to see. But usually what you'll see instead is something like this, which is just a file. Like this is just literally a file. These spaces don't matter. Like there might be all together. For example, we'll see when we output it out, we'll have no space, like really any spacing. Spaces don't count, okay? So anyway, that's how we would load it in. So pretty simple. Like you look at that code, that's pretty small. And it's nice because we use this JSON package right here to load it in the file, okay? So now we can actually do a few things with JSON itself. So we can actually take the JSON and actually convert it into a data frame, which is awesome for us, right? Because now we can actually do analysis like we normally would with any data form. If we import it from a CSV, if we got it from a SQL database, if we get it, in this case, a JSON file, we can put it in there and we can process it really easily. And what's nice is that most APIs that we'll see usually use JSON. That tends to be the newer format. XML still does exist, and it's still useful in that sense that it's there. It tends to be an older format because XML has been around for a lot longer. Or I could be wrong, but XML has been around longer. So sometimes you'll see the more modern versions to use JSON. So a lot more packages uses this. But the first thing we want to do is that if we look back at like when we looked at data itself, so let me go ahead and put in code here. If we looked at data, right, data is pretty big. Like you can see there's a lot going on here. So what you'll have in the curriculum goes through is like, hey, how do you go process through this? And basically you kind of step through it and see what the structure is, because you might not know what the structure of your JSON file is. It might be completely different from this. Hopefully your API documentation will tell you, but there's a chance that you just don't know what it looks like. So the first thing we want to do is like, well, we know it's a dictionary in this case because we looked at it, and we can see actually, oh, there's actually two keys. In that case, meta, we saw up here. And then if I scroll all the way down, we'll actually see data is another dictionary in here. But you can see that could be really tough trying to scroll through all this and trying to find where the next dictionary happens. It can be pretty difficult. So we can actually import these two separately as data frames. Oops, I have to actually make sure I have pandas first. But now we can actually take this, and all we have to do is basically, since everything's just a dictionary, it's nothing special, we can just create a data frame with a dictionary. So this is actually built into pandas. This is not from JSON itself. So now if we do this, we'll actually see that we get 2 data frames in here. And now I can actually, oops, not code. I can actually check out this data frame. So let's check out data, because that one to me looks more interesting. And you see there, we actually get a nice formatted data frame, right? And we can kind of look at real quick if I wanted to just check out what data looks like. Oh, I shouldn't say data. It should be data. Yeah, that's what it should have. Sorry. So just kind of look at like what this would look like before we imported it in there. You can see it's actually the data is structured as a list of lists. And that makes a lot of sense for what we want. Basically, you think of a data frame, it's really like a list of lists. That's what a table is. So it's actually able to format it really nice and easy for us in our data frame. Now, note that not every JSON object, every JSON dictionary can be translated into this kind of thing, into a nice format like, into pandas like this. So for example, if I look at, was like, well, okay, this worked right here with data meta, right? So let me check out what that data frame looks like. And let's just do a head, so we don't have to go through the whole thing. You can see it's a lot different structure. And that's because if we look at what this looked like, data meta, right? We can see here, that's because our key pointed to another dictionary of a dictionary. And so we have to, basically when it reads in that dictionary, it's not a list of lists. It doesn't make any sense in that way of importing it. So it actually imports it much, essentially, if we fed out the whole thing, you'd see all the different values. Okay, so you can see right here, for example, this is a list right here, but we would, maybe sometimes you'd want to actually see that as more of a data frame. So you have to kind of structure it through. So this is all the data. You might just have to finesse it, make sure it's the right format that you want. Any questions on between these two when I imported them through? Cool. So one thing I didn't show you guys is that one thing you might ask, like, well, okay, that's cool. You can do basically that meta dictionary, that data dictionary. Could I just import the whole data that we had right here? This whole big dictionary, including data and stuff like that. And if you actually try this, so let's see here, data frame. Oops. This is a dictionary, right? We saw that it was a dictionary. If I just do this, let's see what happens, right? Value error. So it turns out, if you look at this closely, it turns out that basically the structure of it just can't be translated into a data frame easily. So this will likely, depending on like how your dictionary is done, it likely will get this kind of error. And you have to really parse through and say, okay, how is this formatted? How can I translate this into a data frame or some usable data that you can process? Okay, cool. So just know that exists. All right. So last thing is like, okay, let's say we do a bunch of stuff, maybe mess around with a dictionary, our data frame, we output it into a dictionary, right? We can actually output it now to a JSON. So let's say, for example, you're using an API and maybe you need to pass information back in JSON format, right? You can't pass a data frame to a server. You might have to instead pass it as a JSON. So right here, I made a dictionary, right? This is just a dictionary in Python. Okay? And normally you wouldn't be writing it out like this. Normally what you do is using some other code, maybe you use like something to go from a data frame to a dictionary, exporting it out. So once you have this format, basically it has to be a dictionary, a list. You could have tuples, which are basically interpreted as arrays, and basically strings and integers and stuff like that. But you can't have weird things like classes. That wouldn't work for JSON. But if I try this now, I can actually output it to this .json. And then you can see right here, this is just normal Python, but it uses Json.dump. And this one basically allows us to take the data, which is formatted in a dictionary, list of dictionaries, blah, 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 and export it into a JSON format into a file. Okay, so I run this now, and you'll see it over here once this runs through. Did it go through? Okay, so you'll see here, output JSON. And you'll see here, I have this nice formatted, well, not nice formatted, but it is now in a JSON format. And just to kind of, I think it's easier to see it this way. You can see this long thing where I have a menu, ID, file, value, all the way through. Okay. So that's kind of like pretty much what we'll talk about for JSON. Any questions on any of this? Okay, cool. Yeah, again, not too bad. JSON objects are usually pretty easy to like work with in Python. You just got to find out like, is the structure, the one you need. So that's JSON. XML can be a little more difficult. It's the same kind of concept where we have nesting. So for example, I borrowed this from a website and kind of modified it a little bit. But basically, like XML can be like any kind of format. So for example, this note right here, this note, and then inside that note, there's a to field, a from field, a heading field, a body field. Okay, kind of that's the basic structure. This can get obviously a lot more complicated. In fact, it does get a lot more, and you get a lot more nesting. But we'll see how we can parse it similar with Python. Unfortunately, oh, here's the documentation for Python. Unfortunately, at least in my opinion, XML tends to be a little more cumbersome to deal with. It's not too bad, but you'll go through a little more steps, and it takes a little more, I don't know, mental work. So here I have my sample XML, and you'll notice that this is a package that's built into Python, and I have to use specifically basically getting an element tree. Again, the documentation's up here. It's quite long, but this is how we're kind of structuring through. And you can think of our XML like a tree going through. So the way I picture this is that it's like if you have your very first part, and they always say a tree, but like usually people draw it top down, but I'll draw it up like this so we can kind of say. So we have our root, and then our root might have multiple like nodes, like basically branches, right? And then each branch might have their own little branches, right? And that's kind of like how XML is formatted. So in this case, if I look at this guy, this is actually quite a simple tree. So if I go ahead and do a tree, so it's like, okay, here's my note. That's my root. And then for my root, it's like, oh, well, I have a to field, or a to branch, a from branch, a heading branch, and a body branch, okay? And you could actually have had more branches on top of that. For example, let's say the heading branch had other fields. You could have multiple fields. You could have 2 branches coming off of there with different values. And this can go later really deep, like take a long time. So you can kind of see why it's called a tree, right? But what this really looks like I said, it's just kind of structured like this. So this XML code, if I look at it in here, oops, I guess I can't look at it there. So I have it downloaded already. So our XML code looks like this. And you can see that we have our root here, our response. You'll see the next part is a row. And what's kind of nice is browsers will format it nice and easy for you to go through. So you see there's, response, our root only has one little branch, which is row. But of course that branch row has a lot of other little branches here. And you can see there's some extra values within here. And then you can see that it has more branches within that part. So you can kind of see that there's a lot going on in here. And you can see each branch, in this case, this row has a different format than this one. So you can kind of have a differing kind of structure and stuff like that. Okay. But now if we try to import this through with Python, we can go ahead and run this guy. And so all I did here was read in that file as a tree and getting the root, tree.getRoot. Okay. And this is all in the documentation here. But this is how you would normally proceed through. And now this allows me to say, okay, I'm at that root part, which is the response. And so now underneath here, I'm using a list comprehension. I just kind of showed you guys just so you get used to list comprehensions. The curriculum goes through a little more robust kind of like for loops and stuff like that going through. But I kind of want to get you guys to this. So basically what's going on here is I'm taking the root and saying basically for each node, each branch in the root, which in this case there should only be one, right? Okay, I'll get the node from there and make a list of that. Okay, so that's like my first one. So I call it my first children. So if you think back in our structure over here, you can see like, okay, this would be our first child. In this case, it's the only child. All right. And then what we're going to do, we can get our grandchildren. Okay. So in this case, I'm only going to look at the node in here. So I want to show you guys this multiple list comprehension, but basically for node and root, and then basically for the grandchild in node, okay, I'm going to just get the grandchild. And what that means right here, it's basically for the node and root. This is the node in the root. For this node and root, get the grandchildren, which are basically all of these guys. Okay, and this will get us a bunch of information here. So if I run this now, see it runs out pretty quickly, okay? So now we actually got our tree, right? We have our root, which is our whole tree. I'm getting just the children here, and then I'm getting all the grandchildren in here. And you could have more layers. It could be great-grandchildren, essentially, going further and further down. Okay. but this case, it only goes one layer through. So I can actually check out my first child. Let's actually, I had this before, I guess I took it out, but let's see how many, how big is our list of first children. You can see here, it's just a list of 1, which makes sense. That was just that one row. And so now if I actually do, we can actually look at this tags, this attributes. So you can see here, if I run this, you get row, and then there's no attributes, basically. And you can see what that means is that right here, this row, that's the actual child, okay? What's it called? Its tag is called row. That's what its name is. But there's no attributes. Basically, there's nothing within this part of the XML. Later on, we'll see these are all the attributes right here going on, right? So you can kind of process that through. So now we'll see for great-grandchildren. In this case, I kind of borrowed this from the curriculum too, is we can basically iterate through the grandchildren, okay? Wait, I'm sorry, I looked at the wrong one. Sorry, I misspoke. We're looking at our grandchildren here, and we can actually see how many grandchildren there are. And you'll see there's like about 200, I think, 285. So that means there's basically 285 rows going on through here, right? I went all the way down. You can see how big this is. 285. So again, matches up to what I'd expect. But for each one of these grandchildren, you'll see that I have attributes here. I have ID, I have UUID, I have position, I have address. So now, if I look at just the tag of the first grandchild, right, we'll see its row. See that? So again, oops, row, that's what this is right here. That's its tag. And then if I want to look at its attributes, you can see right here, I get its all attributes. In this case, the dictionary. ID, which is 1, UUID, this whole long guy. And you can see, that's what I see here. ID, 1, UUID, this whole long thing. Next thing will be position, and then address, and that's all of them. In that case, you can see position and address. Okay, so cool. So that's kind of like just showing you the structure in there and how you can iterate through. I could also go to the next tag, right? Or the next grandchild, all the way up to 285. And you can see that it has a different structure here, or slightly different attributes. Okay, any questions on this so far? Thumbs up if you're feeling like, okay, I got it. Sideways, like, maybe not. Okay, cool, see some thumbs up, that's good. Cool. All right. So then this right here, this is, again, borrowed from the curriculum. It first shows you how to do a for loop through basically the grandchildren. But this is probably the better way to do it. It's basically doing iterative. And basically, oops. Here we go. This allows us to basically go iteratively through the root. So we don't have to do it over and over. Like basically, it allows us to do a more efficient for loop. Definitely check out the 2 comparison codes, because the curriculum will do like a for loop and then say, but we could also do it this way. And this is this way, which tends to be a little
Would you mind just pasting that into like Slack?
Sure, yeah.
So you could, yeah, that would be, thank you.
No problem. Yeah, I'll do that right now, since I'll forget.
Oh wait, I have access to it. I'm sorry. You don't need to do that.
Oh, that's right, you guys do.
Never mind.
All right, yeah. You guys can obviously use that link from I sent in Zoom, right? So yeah, you guys can use this, copy it around, and it's also on GitHub, so check it around. But anyway, we have our root, we iterate through it. So each iteration basically will go through all the elements in that. So you can think of basically, these are all the grandchildren. And in this case, basically, they don't want to go more than 10. So that's why we basically cut it off at 10. But we could have gone all the way through the list. It's just that that's a lot of printouts. So we can run this now, and we'll see we get the element.tag attribute. So you can see right here, the first one's response, and then we iteratively kind of go down into it. And this next one's a row, which is what we saw before. That's our first child. And this is our grandchild right here, our first grandchild. Okay. And then if you notice, it actually goes one deeper into there, candid. That's coming from right here, candid. Can name, office, borrow, and cancel class. I have no clue what this data is. I forgot. But basically, you can see here, that's what's coming out here. It's basically kind of digging in deeper and deeper and deeper. And this is what we'll later call depth first. We'll go in deep and then kind of come back out and do it again. So you can see here, we basically reach the end of that, branch, okay, that grandchild and great grandchildren. And then we pop back up to row 2 and go in, and we could have gone further. So if I put this like 20, you'll see that'll get even more values. I think we'll get into the third, yeah. So you can see here, there's some more values here, which come from this directly right here, election, candid, name, office. Yeah. That's kind of like how you can iterate through and get the data in there. Again, a little more, in my opinion, it feels a little more, just more involved than JSON. JSON, at least in my mind, just is processed easier, but know that you'll come across XML every now and again too. So it's a good thing to know. And then to create a data frame from XML, it's a little more complicated. We can't simply just say, oh, just use a dictionary and pull it in. We have to kind of basically create that structure and then create our data frame. So you can see here, this is from the curriculum again, but you can see basically we get our tree root, we iterate through this part. Basically we're getting, in this case, an element and enumerate. So have you guys seen enumerate before in Python? Okay. So if you guys haven't known, enumerate basically creates a list, basically where it is in the list, like it's like 1, 2, 3, and then the element itself. So like, for example, if I just did like for element, so like ignore that n, in root.iter, okay, I could have just simply, that would just be the element each time. But if I want to count each one it is, I can use enumerate. So the first one will be 0, the second one will be 1, and so on. I'm sorry, I think the first one's 1. No, I'm sorry. The first one is 0. So in enumerate, basically you'll have 0 and then the element, 1, then the element, and so on. Okay. And that will create our data frame. In this case, you can see, and this is in the curriculum too. So you can play around with it and check it out. But you can see we create our data frame from here. A little more involved because you have to kind of tease out the structure from it, but you can still do it. All right. So any questions on XML? Cool. Thumbs up? Sideways? Yeah. Just a quick question. I'm curious, which one do you guys prefer? Like, if you guys see XML and JSON, at least from what you've seen so far, would you go JSON?
Yeah.
Yeah.
That's when I worked on integration stuff. JSON was like the standard for everybody to use to send whatever.
Yeah, XML tends to be for older, more established businesses. So for example, when I was working at a credit union, we mostly use XML to communicate different parts, which is fine. It's just, in my opinion, a little more cumbersome. I prefer JSON.
Is that just because it's established and it'd be difficult to,
it's more like, well,
there are benefits.
I mean, I guess in the long scheme of things, it's the same stuff. I think it's just been established more. So people who are familiar with database stuff, they might be looking at XMLs a lot more often. But I honestly don't know if there's this particular benefit because it's essentially the same information. It's just, I think JSON ends up being easier to process through. So because we use it at Python. Yeah. Okay. It's more modern, I think. Okay, cool. So kind of comparing the two formats real quick. This is the same exact data. And this is from this website right here, which is actually really great, json.org. Check it out. But you can see basically that this information is the same format as here. And so one nice thing is that it's kind of, I think this might be easier to read for most people if you're used to like HTML and these kind of markup languages. But I don't know. In the long run scheme, it does the same amount of data. It's just about how you process it. Okay, cool. All right. So that kind of clears things up for XML and JSON. Curriculum goes through it pretty quickly, but also a lot of more detail. So definitely check out the curriculum and go through it. So I don't think there's any questions. No questions, right?